Yeah, thank you, guys. So, yeah, my name is Daniel, and I'm extremely excited to be here and share my modest experience and researches in the Polkadot. So today our topic will be upgradable smart contracts in Ink, and during these 20 minutes, I'll try to draw your attention to WASM smart contracts facilities and show you how that nowadays smart contracts are becoming more and more supported and easy to use. But before starting, let's firstly answer the question that actually is bothering me. Will smart contracts still be a popular solution in future? So today we can see many very complex DeFi applications in the Ethereum ecosystem built purely on the smart contracts like Uniswap or DivideX trading platform. But when they originated, the only two, and sometimes maybe not the best one, was smart contracts on Solidity. Building layer 1 solutions were often beyond the average product team. But nowadays the game is changed, and we have a lot of such great tools as the Cosmos SDK and the beautiful Substrate, which allows developers so easy and so approachable to build their custom blockchain. But does it mean that we should consider a custom blockchain as the only approach to building all of our decentralized ideas? Let's try to grasp the difference between runtime models and smart contracts projects. So, in the first place, these two approaches offer dramatically distant development freedom. While Substrate models, runtime models provide the very low access to the blockchain, smart contracts are more like a sandbox solution. Yeah, of course, nowadays, smart contracts running on the modern blockchain have become more powerful. However, within the smart contract, you can do only the things that blockchains you're running on allows to do. Talking about the fee system, you have absolute freedom to apply any fee system for your runtime module. You can apply fees selectively or even leave the whole system feeless. But if we're talking about the smart contracts, developers should take into account an untrusted input of the contract's code. Anyone can easily upload their code to the chain. Thus, having some gas meters is a minimum to keep the system safe. And by the way, talking about the safety and performance, so performance and scalability should be considered the main focus of layer 1 solutions. However, careless storage manipulations can even break the chain and make it stop forever. Talking about the smart contracts, the chain doesn't rely much on them, on the code of the smart contracts. The expectation of contracts code are quite low. If something unexpected happens with the contract storage, it will be just reverted. But this processing thereby makes smart contracts slow and costly in execution. Oh, sorry. And finally, there is a pitch dark gap in the complexity and cost between these two guys. So building runtime models and then upgrading them to parachain requires to maintain the network and build the community around your solution, which is very complex. And if you're talking about smart contracts, it's just about having a couple of dots in your wallet for deployment of the smart contract, and that's it. Your application is ready to go live. And all this above is leading us to this use case line where smart contracts and runtime models are on different poles. If you're going to build something really scalable, expecting tough computations, you should definitely favor runtime models. But when it comes to decentralized applications, the decision is a bit controversial. If it's still something massive and you are going to scale to the millionth production, then you should probably stay on the runtime models implementation. But if your decentralized application is relatively simple and more community-oriented, like, for example, the blockchain games, then you should look towards the smart contracts implementation. And finally, there are use cases where only smart contracts are the best in class. When it comes to the custom trading algorithm or the custom contracts between the two parties. For example, let's imagine it could be the custom contracts between the players in some blockchain games, or even prototyping of something before going to the parachain. So smart contracts are the only right choice here. Talking about the smart contract support within the Substrate, we have the two very basic palettes. So the first one, well-known EVM palette, which allows you to execute EVM bytecode within the Substrate, like on native EVM virtual machine. And the contracts palette. So the contracts palette is more about the rethinking and upgrading the idea of EVM virtual machine. Firstly, a big benefit of contracts palette is operating with WASM binary, which potentially allows you to write smart contracts on any language that compiles to WASM. And theoretically, WASM contracts should have better performance for some languages and produce lower binary output. So when we first started working on the smart contracts project in the middle of 2020, the list of tools and future parachains which will support smart contracts were way more sparse. But today we're observing the progress in smart contracts adoption. Mainly, at least 4 well-known and great parachains support smart contracts. And one of the noticeable here is the Astar parachain. Actually, this is the only parachain which supports the contracts palette and WASM smart contracts. And they also have this interesting financial incentivize where building the application fully on the smart contracts can be pretty attractive. The more users interact with smart contracts and pay fees, the more profit the owner of the contract makes from this. And even though the tooling is still maturing, you can already start building something really complex on smart contracts nowadays. And that's actually where upgradability might come in handy. I know that sometimes upgradable contracts is a trigger word, but let's try to figure out, is it really a bug or a feature? So the main benefit is definitely the confidence of businesses and developers to start building something complex in a rapidly developing ecosystem like the Polkadot and adapt your solution to the fresh and sometimes breaking changes. But the haters will say that upgradability is a mutability, and they will be right because it contradicts with the central blockchain paradigm and can lead to the loss of the user's trust. But another great benefit of upgradable contracts is that they allows you to deploy products at very early stage and progressively add new features. But on the other hand, it increases the complexity of the logic and can lead to potential vulnerabilities. Of course, although these vulnerabilities can be fixed in the upcoming upgrades, but it won't save us from malicious or careless upgrades that can easily crash the storage and make the product unusable. But does it mean that upgradability is the bug? I don't think so. It only means that upgradability should be integrated consciously in your smart contracts project. So let's check how to avoid all these cons. So the most important part is to delimit the access to the upgrade function. And there are plenty of techniques. So the first step you can consider is make upgrade function only accessible for some external owned address. But yeah, of course, for sure, this way is far more from decentralization, and it comes handy maybe rather for development purposes. So how can we improve this? Yeah, of course, adding the multi-sig address and better diversify the key between the developers from different teams. But still, there can be some bad actor in the system who holds all these keys. So there is another technique called the time locks, which means that upgrade will be applied after some delay, for example, a couple of days, revealing all the upcoming changes to the public. And actually, why it may come in handy? Imagine that there are users who disagree with upcoming upgrades. So with the time locks, now they have time to escape the system if they want. And time locks often goes with the pausable feature. So this pattern allows trusted developers to hold transaction for a while, preventing more harm to the system, and take this time to resolve vulnerabilities. Of course, in hands of malicious admins, this feature can be really abused to push an unwanted upgrade. So the last important ingredient in this decentralized recipe is elected governance and giving the community the voting power to elect their admins. And to summarize, this recipe is not really strict and not complete, but the main idea is the solution always exists, and you can combine these practices depending on your project scale. The next recommendation would be to use the well-tested smart contracts libraries and upgradability patterns. And in Ethereum world, there are a great company, OpenZeppelin, which did a secure implementation for most popular contracts. And in the Polkadot world, we have the OpenBrush, which is a unique solution right now, and developed by Supercolony team, including me as well. And it covers the whole set of OpenZeppelin contracts with a couple of additions and improvements. And only we, as Supercolony team, developing more infrastructural products like, for example, the Sol to Ink, which allows to compile the Solidity code to the ink, and also the type chain, which allows to generate the TypeScript based on the contracts API. So yeah, let's actually answer the question how actually we can write upgradable contracts in ink. So within the Open Brush and the contracts palette, we introduced two ways of making contracts upgradable. The first one is the delegate call function, which allows to execute the code of contract B in this context of contract A. And there are two patterns to use this technique. The first one is well known when you're deploying the proxy contract first. Let's call it the storage keeper and specify the hash link to the implementation. Let's call him the code donor. So that any call you're making to the proxy will be delegated to the implementation code. So actually changing the link to the implementation, you're in fact implementing the upgrade of your smart contracts. And there is also another pattern called Diamond pattern. And it's doing quite the same thing, but inside it's storing the mapping of the methods and its implementational code link, which allows the splitting contract on multiple so-called facets. And another very unique way to make upgrade is directly to set code hash in the executed contract. The only thing you have to do is just to expose the set code hash function within your contract. So I'll try to quickly walk through the pros and cons of each pattern. So I'd say that the benefits of the proxy is simplicity, and there is less space to run into the bug. Diamond pattern has more cool features like splitting the code and saving the execution fees. Moreover, you can apply upgrades selectively for each facet, but it comes with more complexity. And finally, the unique set code hash. So this upgradability approach has minimum computation overhead. And at the same time, the most powerful one. So for example, you can start your project with the proxy upgradable pattern, then upgrade it via set code hash to the diamond, and then in the next upgradability, just remove this feature at all. So of course, it comes with all of the high risk involved. So, and right now, let's stop to talking about the theory and go to the demo. So here you can see the code of the OpenBrush library. The OpenBrush is fully, oh, sorry. Yep. I have to stop the presentation. OK, great. Yeah, so here you can see the code of OpenBrush. There is plenty of examples inside, and actually OpenBrush is an open source product, so you can use it as dependency for your smart contracts project, or just fork it and make some updates which you want to do. So here we are interested in the proxy example, and this is maybe the most simplest proxy contract that can ever exist. So all the hard things are hidden inside the OpenBrush. So to make your to deploy your proxy contract, you just need to do a couple of things just to initialize the forward to. So forward to is actually the implementational code, so-called the code donor. And also, by default, you have to specify the owner, which can actually execute the updates. And also, you have to specify the function forward with the selector wildcard, which actually means does what the proxy should do. So any call which will be made to the proxy contract will be forwarded and fall back to this function, and then delegated to the code implementation. And as a part of upgradable contract, I will use the PSP22. So PSP22 is the fungible token standard. I think you all know what is ERC20. So PSP22 is analog of ERC20 in the Polkadot and contracts palette. So yeah, you can see here that we implementing all this default implementation from the OpenBrush. You can see the well-known methods transfer, transfer from, and also added a couple more features. So I implemented the ownable feature and also the mintable, which has just one method mint to extend the total supply of the contract. And here the noticeable thing you can see is I don't specify anything inside the constructor because I don't really have to use the state of this code. So it will be just using the code as is. And all the necessary initialization logic will be hidden inside the initialize method. So now let's try actually to deploy our upgradable contract. So it will be very easy to do. I will show you. So firstly, we have to deploy the contract which we want to upgrade. It will be PSP22. Okay. Then we just copy in the hash of this contract, and then we can upload the proxy contract. And in the proxy contract, in the constructor, we will specify the hash link to the implementation, and then just deploy. So yeah, actually that's it. That's all the actions you have to do to make your contracts upgradable. So again, you will interact always with the proxy contract. So let's try to do something with the proxy. As you can see, we have the methods which are specified in the proxy, but I can do some trick to replace the ABI of the proxy contract and make it call the PSP22 functions. So I will add the existing contract, specify the address, the name, and here I will replace this ABI with PSP22. Save. And OK, it's working. And right now, you can see that here I have the all the methods from PSP22. So let's first try to initialize and add some initial token supply to the contract. As you can see, it's added with the 12 decimals, of course. And let's mint a couple things to the Bob. For example, he have a birthday, and I'm chip in some tokens to the Bob. Let's execute, and let's check the balance of Bob. So yeah, balance of Bob. And yeah, Bob has his 10 tokens for the birthday. OK, great. So we just now deploy the upgradable contract. And now let's try to upgrade this. So how are we going to do this? So firstly, I want to remove this mintable feature. I want to unexpose the mint function so that anyone, the owner of the contract cannot mint more tokens. After that, I want to implement the pausable feature for my contract. And OpenBrush documentation will help me to do this. And we have really a lot of useful cheat sheets here, which will help you to lose the features from the OpenBrush. So the first thing is to implement pausable. I have to copy. I have to import the pausable feature from the OpenBrush. Let's do this. And then, of course, OK. Yeah, then let's rename the crate, make it PSP22v2. OK, done. And the next thing I have to do is to import a couple of traits from the pausable. Yeah, it's also easy to do. OK, so now seems like I have everything I need. So after that, I have to expose a couple new fields in the storage. For sure, we have to store somewhere, is the contract spouse or not. So I will add these extra fields to my contract. And then also I have to tell OpenBrush which field to use for the pausable functionality. So I will have this special marker. And now OpenBrush understands that pause is the field that have to be used. OK, also I want to add a couple methods from the pausable trait. So I will implement this trait for my contract. And here I just added the pause trait, which is just a getter of pause to know is the contract pause or not. So, and the most interesting part is to implement the pausable feature. So there is a method inside the PSP22 which will be called before each token transfer. So it's named the before token transfer method. And I will implement this functionality here. So the idea is to, if a contract is paused, I want to return the error. If not paused, then everything is OK. But I don't really want to implement this stuff here, because I already imported some useful features from the trait. And here we can see we have the when not paused modifier, which actually do what we want. So if the instance is paused, we return the error. Otherwise, everything is OK. So let's try to copy it and reuse this modifier inside modifiers. OK, great. So right now, the functionality is working. And the last thing, I have to actually remove the change in the total supply during initialization, because my contract is already initialized. I need just to upgrade it. And finally, I want to expose some method which will allow the owner of the contract to change the state. So let's call it toggle pause. And let's make only owner be able to call this method. So if the token is paused, we will unpause it. Otherwise, we will pause it. So, and actually, that's it. That's all I want to do. Let's try to compile my contract in the offline mode. I think I have a couple errors here. OK, I will quickly fix it and recompile again. Yeah, it takes a couple seconds more. And then I have a small script. We will copy my artifacts to the artifacts folder. And here I should have, yeah, here I have the V2 version of my PSP22. So let's go to the final step and grade my PSP22. So the first thing, I will upload the code, PSP22, deploy it. And then I have to execute an upgrade. So the first thing I have to return the ABI of the proxy contract where I have the upgrade method. So it's very easy to do. The proxy and load in the proxy contract ABI. Great. And here, this is the upgrade function, which I have to call. So I have to provide the new hash link in my proxy contract. So it's very easy to do. We go to the change delegate code, apply a new hash. Let's check, is it the right hash? Yes, it's the right hash. Execute, and voila, we upgraded just our contract. So let's try to check if we did everything fine. So for this, I will do the same trick with replacing the ABI. I have to load the ABI of V2 contract and save. And finally, we got this. So what do we have here? You can see that the storage isn't changed. We still have the total supply at 10 tokens, which we just sent Bob to the birthday. But we don't have the mint functionality. We don't have the mint function. If you try to call the mint, you will receive the contract trap, because in your implementation, this method doesn't exist. But we have the pause functionality. So let's try to check it. Let's try to send Bob a couple more dots. And for example, it will be 5. OK, and let's check the balance of Bob. So the Bob right now have 15 tokens. And right now, let's try to pause this contract. Execute. So I'm just pause it. And if I then try to send something to Bob, I receive the contract tab because the contract is right now paused. And if we check the balance of the Bob, we will see that he didn't receive this money because contracts are paused. So let's return to the presentation, and I think I'm finishing. Let's try to summarize everything. Although runtime models and custom blockchain solutions are gaining a lot of popularity nowadays, smart contract will always have its own niche and dedicated use cases. Upgradability gives us a lot of benefits, like the deploying the product on the early stage and always leaving the chance to fix the vulnerabilities and progressively add new features. But in the same time, I'd say that upgradable contracts is not a bug if they are developed consciously with decentralization in mind. And there are enough tools and parachains to build complex smart contracts projects in Polkadot nowadays. So just make a revolution. So this is the team of Supercolony which is working on OpenBrush. So we have 3 developers, CEO and product owner. And here's the links. So we can answer any question about the OpenBrush in 3 channels, in Telegram, in Element, in Discord. This is also the links to documentation and website. So you are very pleased and very welcome to check it. So yeah, thank you very much. Thank you for your attention.